At a certain point in my life, while studying scientific papers regarding signal transduction through G-protein coupled receptors, I turned my attention to signal transduction damages that were being discovered in patients who had chemical dependencies. It occurred to me that perhaps, with a little creativity, the damage caused by drugs used could be ameliorated by changing the nutritional environment that bathes the damaged cells, just like the cell culture media was bathing in the culture cells. There are so many contributions made by so many people in the field of signal transduction and receptor desensitization and addiction pathophysiology. It's very difficult to create a chart or a list without slighting somebody. But I would say that one particular important piece of knowledge in the puzzle I was solving come from a large body of work on G-protein and on the G-protein coupled receptors. It was fortunate for me, again, and this was luck and time, it was fortunate for me that a large number of people were publishing articles on these signal transduction molecules, particularly in the 1980s, and definitely continuing on into the 90s, and even today, into the 2000s. As we know, G-protein stands for guanine nucleotide binding protein. G-proteins are a family of heterometric proteins made up of alpha, beta, and gamma subunits involved in second messenger stimulation. I'm sure you know there are three major classes of second messengers: cyclic nucleotides, inositol triphosphate, and diacylglycerol, and of course calcium ions. Now everyone knew that. They're called G-protein because they bind GTP. And they function as molecular switches that alternate between binding guanosine diphosphate when inactive and binding guanosine triphosphate in an active stage, and ultimately regulate downstream cell processes. Now, I think it's a little technical. But G-proteins were discovered by Alfred Gilman and Martin Rodville when they tried to figure out how adrenaline stimulated cells. They found that when a hormone like adrenaline became bound to a receptor, the receptor did not directly stimulate enzymes of adenyl cyclase. Instead, the receptor stimulated a G-protein, which then stimulated the adenyl cyclase to produce a second messenger called cyclic AMP. For this discovery, they won the Nobel Prize in medicine in 1994.